Dear student of class 8, in the chapter force and pressure, we have already discussed about some topics of force, like definition of force as push or pull motion. Wherever we are doing some work, some force is applied by us and the change in the position of the object takes place. So you can do the activity as it is already given to you, I think. So you must have done, and then you can see that the force can change the state of an object, whether it is at rest or in motion. We can change its state from rest to motion or motion to rest. Similarly, you have already done the activity in which force can change the shape of an object, activity 11.5. So you are aware of this, that like dough, we are pressing it, or clay, to change its shape, and force can change the shape of an object. Some examples you can do and fill this table as it is already given. And it is the interaction between the two objects, and you are aware of the balanced and unbalanced force, like box is being pushed by the boy, and you can see that the object is moving from one place to another. If both the forces are equal, F1 is equal to F2, then it will be not moving from its position. However, either one is greater or smaller, then it will change its position from one side to other. So if it is equal, it is called balanced force. If it is not equal, then it is called unbalanced force. You are aware of it, right? Similarly, tug of war example, in which the rope is being pulled by both the teams and it is balanced or unbalanced forces. So the example are clear to you. Or a person is pushing a car, or girls are playing or pulling any animal by teether. So that we have already discussed in this chapter of force and pressure. Other than that, you are also aware of the topic as contact force. We have discussed as muscular force, and frictional force as contact force, and muscle power, which is used for our body to lift or do anything, that is muscular force, like archer we discussed. And that frictional force always acts in the opposite direction, like a ball is rolling and is being stopped by the earth or inclined plane, as we have discussed earlier. Similarly, non-contact force, where the two objects are not in contact. Magnetic forces, in which two magnets may attract or repel based on the same poles. If they are together, they will repel. North-north will repel, south-south will repel, but north-south will attract each other. That you are aware of the magnetic force. And other than that, we have discussed about the gravitational force, as every object is having its gravity to apply force on each other. That is the gravitational force. Like earth is pulling every object towards itself, we say the gravitational force of the earth. And electrostatic force is the force between the charges. Like when we are rubbing a scale, plastic scale, on our head, and then piece of the paper is being lifted. You can do this activity at home, okay? Or on birthday balloon that you are using, you are rubbing it on the clothes, synthetic cloth, and you can keep in the on the wall. It will automatically stick. Why? Because the charges, it is charged. By rubbing the object with each other, it gets charged. So if same charges is there, positive and positive, they will repel. If positive and negative is there, they will attract each other. Means the balloon and the wall is having opposite charges. That's why they stick to each other. So you are coming across such examples in your daily life, where you can observe the charges, like a straw, which is acquiring the charges. Here the activity 11.7, you can do this at home with the plastic straw and cut into equal pieces, and you have to rub it one, and with the sheet of the paper you can observe that it is being pulled or attracted. So this shows that it is charged, as here in the activity. Okay, then we comes to the next topic of this chapter, that is pressure. Pressure is the force per unit area. Whatever force we are applying on any object on that surface is the area. As you have studied in the mathematics, you are aware of the area. I hope. What is the area of a square? You are aware, side into side. Area of rectangle, length into breadth, correct. Similarly, whatever the surface on which the force is being acted, like a brick is kept on the table, so the bottom surface of the brick, that is rectangular, it is applying force on the table. So some force is given, for example 50 Newton, and the area of the surface on which it is being applied, length and breadth of the brick. So we can calculate by dividing force by area, we will get the pressure. So P is equal to F upon A. So by this you can easily calculate the pressure, which is equal to force upon area. So area of square, rectangle, whatever surface, circular surface is there, then what will be the area? You know the formula of area, pi r square, in mathematics and physics is applied mathematics. So if you are good in maths, you can easily calculate. So you must practice daily 20 questions of maths also, then you can solve this very easily. Okay. So the formula is pressure is equal to force upon area. Now here you can see that the pressure is in the numerator on the left hand side, and area and on is equal to is there, right hand side force and area is written. So pressure and area, they are inversely proportional, and pressure and force, they are directly proportional. Pressure and area are inversely proportional. Directly proportional means if the pressure will increase, then force will also increase, or you can see that force will increase, then pressure will also increase, vice versa. If force will decrease, pressure will also decrease. So that means directly proportional. And inversely proportional means when pressure will increase, area will decrease, or area will increase, then pressure will decrease, and vice versa. So we have a lot of application of this, as you are carrying a school bag in which the strips are very thick. So area is more of the belt, okay, the bag you are holding on the shoulder, okay, that strip is very thick one, so that area becomes more, and so pressure is less exerted, because pressure and area are inversely proportional. So if we are increasing the area, pressure becomes less, that's why. Okay. Similarly, other example you have to find out, like sharp edge of knife. What is that? Very thin part is cutting any object, means area is what? Very less. So area is less, then pressure will be what? More, correct, because they are inversely proportional. One will be more, then other will be less. If one is less, other will be more, correct. Okay, so it is clear to you, I hope so. Now similarly you can see that the pressure is exerted by the liquid and gases. Liquid also exert pressure, like you can do this activity in which you can take one hollow pipe, okay, and in this activity 11.8 you can tie it with the balloon, and you will fill it with the liquid, as you can see here in the diagram. So when the liquid will be filled, the balloon will be inflated, so the liquid is applying pressure to the liquid from all the direction. So Pascal's law is there, whenever pressure is applied on a confined liquid, is transmitted equally in all direction. So the unit of the pressure is Pascal, okay, you can keep this in mind, like we know the formula of the pressure, P is equal to F upon A. P is equal to F upon A. So what will be the unit of pressure? Will be unit of force divided by unit of area. So unit of force is Newton. Force is always calculated in Newton, and area in unit square, like meter is there, so meter square. So Newton per meter square will be the unit of pressure, Newton upon meter square. So we can write this by another name also, which is called Pascal, PA. So this is the unit of pressure, right. Now other than this activity, some more activities are given to you which you can easily practice at home, like waste plastic bottle. In this activity 11.10 it is shown that you can take the bottle and make hole from some sides at the bottom, and you will observe that the water is coming out from all the direction as shown in the diagram. So it is applying, water is applying pressure to all direction in the bottle equally. Okay, to every direction it is applying pressure in equal amount. So that is the activity which you can also show to do to confirm that liquid exert pressure. Similarly, air exert pressure, like in the birthday balloon you are inflating and you are pinching something to the balloon, or it is hit by something, then it will blast. So what happens? So the air inside the balloon, it exerts pressure, and wherever it gets the space to escape, then it bursts. Okay, now here other activity, you can see that the bottle one, in which one hole is made and you can fix pipe, and to observe that the balloon will be inflated when more liquid is filled in this. So I hope it is clear to you. You can do these simple activities at home very easily to observe that the pressure is exerted on by the liquid and gases. So we say that 5 kg of any object, like you are purchasing from the market. What do you mean by 5 kg? This is the magnitude, okay, of weight that we are purchasing. Or the length, you can see that 2 meter length is there. What is here? 2 and meter together we call it magnitude, okay, of the length. Here 2 is the numerical value, meter is the unit. So together numerical value and the unit make the magnitude of any quantity. What we call it? Magnitude. All of you repeat it, magnitude. Okay, so similar to the magnitude of force is, for example, 10 Newton. What does it mean? 10 is the numerical value and Newton is the unit, correct? So together becomes the magnitude of the force. Similarly, pressure is calculated as force per unit area becomes some numerical value and the unit as Pascal. So together we call the magnitude. So magnitude is clear to you? Okay. Now the application of this pressure, you can see that the liquids are exerting pressure as we have done this in this activity. And other than that, air above your head. All of you are aware of the earth and its structure, and air is there above our head to some level, and then to some kilometers, then these are some weight is exerted by the air above our head. By the formula you are aware that P is equal to F upon A. So some force is exerted by this air column above your head and the area of your head over which it is being applied. So we are exerting pressure of the air from on our head from the atmosphere. That is called atmospheric pressure, is the pressure exerted by the air on every object, not only on us. Every object on the earth is being exerted by this atmospheric pressure. For example, here activity 11.11, you can see that rubber sucker, we are using this to fix on the wall to hang something, with one end as a hook is there, and this surface, curved surface, we are fixing it on the any plane surface like mirror. You can keep it, fix it. So what will happen? The air inside it will be taken away completely when you will press it. In this activity you can read it. I have sent this, I am sending this all the pages of this chapter to you, so that you can go through with this chapter thoroughly, read it loudly, make habit of reading loudly daily at home. Okay, this will help you very much. Sometimes I observe that the students are not able to read because of this. So you must practice daily, or 10 minutes at least loudly you have to speak it at home, the whole chapter. Okay, now let us come to back to here this topic. Here this rubber sucker, you can see that the air is taken out, and due to the atmospheric pressure it is sticking on the surface where it is fixed. Now it becomes very difficult for us to remove where it. Okay, so this is another example of the atmospheric pressure exerted on the object. You can write whenever it is asked in the exercise questions later on, or elsewhere in daily life you can find out. Other than that, like two balls are there. Here you can see this activity in which horses are pulling, we know that the horses are very much powerful animal like tug of war, and they are pulling in opposite direction. Okay, still they are not able to break this because the air is there and it is vacuum is there, so air exert pressure, atmospheric pressure, it is not able to remove very easily. Okay, now as we were discussing about the pressure exerted on our head, you can see here diagrammatically it is represented that the atmosphere above our head exert pressure, that is atmospheric pressure. So P is equal to F upon area, and area here is the area of your head. For example, it is 15 centimeter by 15 centimeter, so it will be like this. So you can easily calculate if the force is given and area is this much, you can calculate the how much pressure is exerted on our head. This is your activity. All this activity you must do in your copy, and practically you must try to do it and write down the main points whatever is left. Okay, in this pressure chapter topic, as force we have already discussed through our videos and the notes which I have sent already earlier. Now other than this, you can see that example you have to write down yourself, like we are lying on the bed or any on floor, so you can find that the more area we are covering. You are aware of the area in mathematics, like brick is standing and brick is lying, so you can see that the small part is there when it is standing, when it is lying then the more surface is in contact. Similarly, when we are standing and when we are lying, when we are standing only the force is exerted by our shoes, so area is very less only of the both the shoes. However, when we are lying on the surface, then whole body exert pressure. So in which case area is more? Area is more when we are lying, so area is more, then the pressure will be less because they are inversely proportional. Correct. Similarly, when we are standing, area is very less, so the pressure will be exerted more. Okay, so I hope it is clear to you. Directly proportional and inversely proportional, as you can apply. Now based on this, whatever we have discussed in this chapter completes, and you can easily complete the exercise question. Here you can see that in the first question, give two example or situation where you have to apply push or pull motion to change the object. As we have already discussed, you are aware of it and you can easily do these questions of exercise. And other question, give two example of situation in which force is applied to cause change in the shape. Okay, I think theoretical part is clear, so you can easily complete all the questions whatever is asked related to that. So fill in the blanks also you can complete. To draw water from the well, we have to pull or push the rope. Accordingly you can fill the table, fill in the blanks and complete the activity based on this chapter, that you are aware of it, and I hope that you can easily complete the exercise based on these topics. Okay, and I will be taking one test of this chapter on the next Thursday. Okay, so be prepared for this, and I expect that everyone should they are making notes of these topics. And let us see. So here the next questions you can complete here. Archer is stretching the bow, which force is being applied by him? As you are aware that contact force, his muscular force is applied, so you can easily understand and do all the questions which we have discussed in theory. If you have any problem, you can contact me in the time schedule, as you are aware, to my personal number as per the schedule, 5 to 6 p.m. if you have any doubt. Okay, I hope